All right, marvelous Algebra 1 students, you came back for more. Lesson 6.4 is definitely required viewing before this one because all we're really doing is taking everything we learned and expanding it into slightly stranger, maybe slightly more difficult equations. There is an opener for today, so we're going to have you try those and then we'll go over them together. And then there's going to be a practice problem set that you'll do, and then there's a create your own practice problem set. And that's it. So again, we're not really learning too much new. We'll talk about what the maybe new things are at the beginning, but that's about it. So good luck on the opener. If you get stuck, you can watch my video. You can always skim through until you get to the problem you need help on. All right, so let's begin. Problem 1. We learned a two-step process for last class, and the very first step is we needed to make the bases the same. I gave the suggestion that it's usually easier to make the larger base the same as the smaller. So I'm not going to change 5 at all, that seems smaller. I am going to change 25, but what doesn't change, at least initially, is the x. And so I always like to group the base that I'm changing, that 25, but keep everything else the same. What does 25 become? 25 becomes 5 squared. The reason we chose that is because 5 is the same now on both sides, and 5 squared is the same as 25. That's always step 1. Now, continuing step 1, I am going to simplify each side so I can get rid of those parentheses. To do that, we remember we have an exponent on the inside of parentheses and an exponent on the outside of a parenthesis. We need to multiply those together. So this becomes 5 to the 2x. Once we are here, once we have a single base on each side and a single exponent on each side, we move to step 2. Step 2, now that we have made the bases equal, we're going to take the exponents, x plus 3, and 2x, and figure out what makes them equal. Now this is different from anything we did on 6.4 because now we have x's on each side, and it might have been a while since you solved equations like this. To solve an equation like this, the first thing we want to do, assuming everything is simplified, is move all of our x's to one side. And we always do that using addition and subtraction. That's what comes first. Right? This x and 3 are separated by addition, so I'm actually going to go ahead and say, well, that's a 1x. I'm going to undo the 1x by subtracting it from both sides. We like to move those x's to the same side. These cancel, and that gives me 3 equals, well, 2x minus 1x is 1x, and we should know we don't even need the 1 in front of the x, so we just get x equal to 3. All right, let's go ahead. We're done with the first. Let's try the second. Problem 2. We want the bases to be the same. We keep the smaller base here. We change the larger base. 10 to what power is 1,000? And hopefully we are using that chart of perfect squares and cubes to see this is 10 cubed. Simplifying down a bit, we end up with 10 to the 3x. All right, now we take each of these exponents and we end up with x plus 2 equal to 3x. And we move all the x's to one side. So I will take this x here, I'm going to subtract it from each side. That gives us 2 equal to 2x. And then finish out by dividing by 2. Anything divided by itself is 1, and so we find that x equals 1 for this problem. Should make sense too, because if you substitute 1 in here, 1 plus 2 is 3, and 10 to the third is 1,000. 1 here, 1,000 to the first is 1,000. All right, problem 3. Let the trickiness begin. I think you're going to have trouble rewriting 125 or 25 as a base to a power. In particular, I don't know 25 to what power gives me 125. 25 to the first is 25, and 25 squared I think is 625. We skipped right over it. Drat. Well, if that happens, we might want to look to that table of perfect cubes and perfect squares, and we could maybe see then that they both can be rewritten as 5 to some power. So what we're going to do is we are actually going to change both of the bases into a smaller base. We are going to change 25 into 5 squared and 125 into 5 cubed. Now, I did mention that simplifying each side is going to be useful, and we know we have to multiply these together. To multiply those together, though, we need to multiply the red 3 times everything in black, which means, that's right, distributive property. So we end up with 5 to the 3x minus 12. Same thing here, 5 to the 2x minus 12. Now, when we set the exponents equal, 3x minus 12 equals a 2x minus 12, don't lose sight of the fact that we want to move all of our x's together first. Don't worry about the 12s, work with the x's. I'm going to subtract 2x from each side. That gives me 1x minus 12 equals negative 12. Now we can worry about the 12s. I'm going to add 12 to each side. And instead of 1x, we can just write x. That's the same as 1x. And negative 12 plus 12 is 0. Don't forget 0 is a number. It has feelings. It tells us that 0 is the number that will make the left side equal to the right. 3 to go. All right. Do we need to change both bases? I don't think so on this one. I think we can change 8 to be 2 to some power. So we end up with 8 being 2 to the third power. The only trick here is that distributive property. So we end up with 2 to the 3x plus 3. 3 needs to go to both, and 2 to the 2x. Then we take our exponents, 3x plus 3 and 2x, and find what makes them equal. You have your choice. You can subtract 2x from both sides or 3x from both sides. I'm going to subtract 3x from both sides because then at least it isolates the 3 that's on this left side. And so we end up with this guy. And maybe we've learned now that you could divide by negative 1, but you might also learn that if negative x equals 3, then negative 3 equals positive x. Fifth problem. All right, I see this fraction. We should be thinking negative exponents here. This is 2 to the first. I'm going to change that fraction by bringing 2 to the first up, so it's 2 to the negative first. We learned this last class as well. And then we simplify by distributing that negative 1. 2 to the negative 1x plus 2. Now to the exponents. 1x is on this side, and negative 1x plus 2 is on this side. Add 1 to each side. This gives me 2x's equal to 2. Divide both sides by 2. And we find that x is equal to 1. Last problem. Okay. Oh, this looks weird. We have 2 bases on the left side. Oh, but luckily the 2 bases are equal. And we learned when you multiply the same base, then what do you do with the exponents? That's right, you add the exponents together. So this becomes a single base of 3, and then it's 4 plus x minus 1. The right side is also weird because it's just plain old 3. Does that have an exponent? Certainly, give it an exponent of 1. We should realize that there's an invisible 1 in front of the parentheses here, but if you multiply by 1, it keeps everything the same. So really, you can actually drop your parentheses and just combine your like terms. 3 to the x, 4 minus 1 is 3, equals 3 to the first. Now take your exponents, x plus 3 and 1, and finish solving. And we end up, after that scary looking original problem, of getting a nice answer of x equals negative 2. All right, well, that's really the hard part of today. And so what we really need is some extra practice to make sure that's all cemented down. You can work with one other partner in class on these next 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions. We're going to work until the first few people finish, or for 20 minutes, because we have one more activity for the day. Once you are done, make sure you check your answers with your teacher, call them over so they can check your work, and then we are moving on pretty quickly. So, 20 minutes, ready, set, go. All right, and you're back. If you already had this checked by your teacher, you can totally just skim the video forward. If you want to see how you did, you can listen through, play it at 2 times speed, whatever works for you. But I am going to go through each of these, but pretty quickly. So here we go. All right, bases are the same, exponents. Actually, I think I can probably stop here, can't I? You should recognize something about that. But if you don't, we can at least undo the x from each side with subtraction, always addition and subtraction to start, and we end up with 1 equals 1. Do you remember what that means? If the x's cancel out and you get a true statement, that means there are infinitely many solutions which make the left side equal the right. And that should make sense because the original problem, the left side is the same as the right. Any number you try will make the left side equal to the right. All right, let's move on to 2. All right, same base. Nice, they already did the work for us. So x equals 2x minus 3. Let's go ahead and solve this one. We can subtract 2x from each side. That's not too bad. There's a 1 here. 1 minus 2 is negative 1, or just negative x equals negative 3. And we'll quickly learn that that means x equals positive 3. You could divide or multiply both sides by a negative. Looking good so far. Moving on. 2 to the x plus 3 equals 2 to the 3x plus 2. Nice. 3x plus 2. Okay. We're going to subtract that 1x from each side. And I chose to subtract 1x here because 3 minus 1 will give me a positive 2. And for some reason, I always like to make my x's positive. I won't say always, but most of the time I prefer to make the x's positive. Okay. Continue working through. Subtract that 2 from each side. Getting this extra practice in from last semester in case you forgot any of your equation solving skills. Finish this off by dividing by 2. Don't forget, you can always keep this as a fraction as a final answer. 1/2 equals x. You could also put 0.5 if you want to do a little more work. Problem 4. All right, we've got to change one base here. Which one's larger? The 9 is larger. So we end up with this, and 9 becomes 3 squared. Then we simplify this. Remember, we don't add to an x. They're separated by a parenthesis. We multiply those together. And then we take the exponents. 2x and x plus 4, and we finish solving. Subtract 1x. I like to move the x's to the same side away from that number. You'll work on it. If you did it a different way, it will still work out. We get 1x, which is just x, equals 4. All right, 5th one. I think we just have to change this larger one, this 8, to match the 2 that's over here. And 8 is going to become 2 to the 3rd power. Then we distribute the 3, so we end up with 2 to the 3x minus 3 equals 2 to the x plus 2. And last but not least, we deal with the exponents. Okay, you could subtract 3x from both sides, but if you do that, then you're going to get negative x's. So I'm going to go ahead and subtract 1x from each side. That'll keep my x's positive. That gives us 2x minus 3 equals 2. And I've run out of room here. So 2x minus 3 equals 2. Let's add that 3 to each side. This gives me 2x equals 5. And last but not least, I think we divide off the 2. And we end up with x equals 5 halves, or if you wanted the decimal, that's 2.5. 3 problems remain. Okay. Oh, nice. The exponents are already, or the bases are already the same. That saves us that nice step here. We can end up like so. Bring all the x's to one side. I'm going to add 3x to each side this time. Get that practice in. Keeps all of our x's positive. So we can now add 9 to each side. Gives me 10 equals 4x. And so we should probably divide off the 4 to each side. When we do that, notice the answer is already a fraction 10 over 4. But I think you could divide both the numerator and denominator by 2 to get you 5 halves, or 2.5. Last 2. Oh, no, there's 4 more. I did not realize that. Awkward. All right, 25 we're going to change into 5, because I know 5 to a power is 25. In particular, I think 5 squared is 25. Distribute the 2. We end up with 5 to the 2x minus 8 equals 5 to the 3x plus 1. And now we deal with those exponents. 2x minus 8 equals 3x plus 1. Let's try to be efficient here. Let's do 2 steps at once. I'm going to go ahead and subtract 2x from each side, and that's going to cancel out the x's. All the x's are on the right, so while I'm doing that, let's subtract 1 from each side to get rid of that guy. If you followed that, you're a true expert. 3x minus 2x is just 1x, or 1. Negative 8 minus 1 is negative 9, and now we solved. 2 steps at once. Masterclass. Now we actually have 3 to go. Well, I was checking just to make sure I wasn't lying to you. All right, 4 to the 2x plus 1. 64 just becomes 4 to the third. No, this is a nice one. We only had x on one side. There's going to be less work this time. 2x plus 1 equal to 3. Subtract your 1 from each side. Not too bad. 2x equals 2. And divide both sides by 2. X equals positive 1. All right. 9 to the 2x plus 1 equals 27 to the x. Uh-oh. I don't think 9 and 27. 9 to a power isn't 27, at least not nicely. I think we'll have to change both of these. Da-da-dum. I think 9 is going to become 3 squared. And 27 will become 3 cubed. There we go. And to simplify, we do have to distribute. We have to multiply. So we end up with 3 to the 4x plus 2 and 3 to the 3x. All right, exponents. 4x plus 2 equals 3x. We'll subtract that 4x from each side. Gives us 2 equals negative 1x, or 2 equals negative x, which means x equals negative 2. Last one. 4 to the x minus 3 equals 1/16 to the x. 1 over 16, or 16 rather, looks larger, so I'm going to change 16 first. That becomes 4 squared. Do an arrow so I don't run out of room here. So 4 to the x minus 3 equals, and then we bring that 4 squared up. So it becomes 4 to the negative second. And then one more arrow. We have 4 to the x minus 3, and if we distribute or multiply, we get 4 to the negative 2x. All right, let's take those exponents. We end up with x minus 3 equals negative 2x. Your choice on how you want to do this here. I'm going to subtract 1x from each side. Even though it keeps the x's negative, it helps to start isolate the number that doesn't have x, so negative 3x. Divide both sides by negative 3. And we end up with positive 1 equals x. Woof! You guys have now gone through pretty much the trickiest problems we can throw at you. So now, let's see what you guys can throw at each other. Your teacher hopefully has passed out an index card or a note card to you. And what you're going to end up doing is you are going to be creating your own problem. So on the front of your note card, you're going to write down a problem that uses exponential equations. You can make it an easy one like problem 8 that only has x's on one side, or you can make it more challenging like 7 where it has x's on both sides. You can choose if you want to change both bases like 9 or just one base, or if you really want, you can make the bases the same, but that's kind of boring. And here's the kicker. You need to be able to solve your problem. So you can make it as tricky as you want. As absolutely tricky as you want, but you need to be able to solve it. But you're not going to solve it on your note card. So you're going to write your problem here. You're also going to put your class period. Your teacher is going to collect these and use them later on, and also your name so we can hunt you down in case something weird happens. Then, down below on this piece of paper, you're going to write your problem again. Right? You're going to write whatever your problem is equals whatever over here, and then you're going to do all the work on your paper. Work, 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 and we end up with whatever x equals. Once you find that answer is going to go on the back. It's going to be x equals something, no work. We don't want any work on the card, just a problem, period name, and the answer. The reason we don't want work is because we don't want people, when they get your card, you're going to be passing this around to just copy down your work. So, problem, class period name, an answer. So why don't you take a few minutes, come up with a problem. It needs to be different than everybody else in the room, and especially the people near you. So don't share with others, come up with your own. Ask your teacher and your group mates if you need help creating one. Okay, go ahead and solve it, and then unpause this video when you're ready. All right, you should now have a problem on your index card. You should have the work down here, and you're ready to rock and roll. You are going to be getting rid of your index card, not by throwing it away, but by trading with somebody else. So you're going to find anybody else in the class, and you're going to switch your problem, your card, with theirs. You're going to take their problem, and you're going to go sit back down away from that person. You're not going to work with the person who made the index card. This is somewhat of an individual activity. Once you've done that, you're going to solve their problem right here where it says problem 2. You're also going to write the person's name at the top, because that should be on the card. You'll write the actual problem, and then you'll show the work, and then you'll get an answer at the end. Once you've done that, flip their card over and check their answer against yours. If it matches, great. You get to move on to the next person. Don't get your index card back. Just take the one you're holding, find someone else in the class, and switch with a card that you haven't received yet. Take that, sit back down, and do problem 3. Now, if your answer here doesn't match the person's answer on the index card, then you're going to use the name, hunt them down, and ask them about their answer. Ask nicely, and you're going to compare your work. You need to decide on who's correct. If they are wrong, and it happens all the time to me, to anyone, they're going to need to change their answer on the back, erase it, write the new one. If they're correct, you'll need to change your work and your answer. And that's that. There are 9 spaces here, which means you need to finish 9 note cards, or 8 in your own, to get out of class today. So good luck with your creativity. You can make it as challenging as you'd like. And this is our last day of really solving algebraic exponential equations. We're going to jump into the graphing section of this unit to finish off our topic. Thanks again, and I'm excited to have you back next class.